A circle is a set of points in the plane located on a curve like this one. So how we can characterize a circle? It's all the set of points that are at equal distance from a center. A center. So if we call this center has, let's say, has coordinate x, y, and y, x0, y0, then we can characterize this circle by all the points that are located at equal distance of, since it's the same, let's call it R, okay, at equal distance. So the circle is the set of all points in the plane, so points with coordinate x, y, such that the distance OM equal to R, okay? If you, let's just see how then we can characterize using coordinates which relationship is satisfied. So we know that if M is a point M here has coordinate x, y, okay, so then the square root, so the distance is given by the square root of x minus x0 square plus y minus y0 square, okay? So we'll take the square root. And OM square, we want that we want this distance to be R. So we will consider all possible points that are such that also if you want to avoid the square root, we can take the power to both sides and get the expression x minus x0 square plus y minus y0 square equal R square. And this is what we call equation of circle, okay? So this is exactly the equation. Sorry, here I missed the bounded brackets here. Uh, um, yes, x0 square plus y minus y0 square. See, so this is the equation, the Cartesian equation of uh, the circle centered at x centered at x0, y0 with radius. So this distance, constant distance equal with radius r. Okay. So yes, and we can show that any equation of second degree like this one is an equation, a circle can be an equation of circle. We will see a few examples how we can do that, or an empty set, or yes, or reduce it to 1 point. We will see an example for that. So so three elements characterizing the circle: the radius, the center. Uh, yes, knowing that we can formulate the equation, and inversely, if we have the equation, we can identify the center and the radius. So let's see the following. Let's do an exercises here. Exercise here, asking here. The first one, find the circle centered. Find the equation of the circle. Okay, of the circle centered at the 1, 3, and passing through the point at -2 and -2. Okay, so let's just try to visualize this. So here is my center 3. Yes, so I have my point here, the center 1, 3, and then passing through -2, -2. Okay, so if they are saying that I have a center, so they have a center, and my point is on the circle. This one is another point. That means, so let's call it a point P0 key. Okay, on this one P0. this one P and the other one. So P has coordinates -2, -2. If that means I have the center, I need the radius. The radius then will be exactly this distance, P0, P. So the radius, I can compute already the radius. The radius will be P0, P, the distance in terms. So it will be square root of 1 minus, yes, the difference of the two, let's say -2 minus 1 square plus -2 minus 3 square, which is square root of 9 plus 25, which is 34. So the radius, yes, the radius will be square root of 34. Okay. Now the equation of the circle is now is we don't so easy. We can just use this formula. Now we can use it. Okay, we don't have to go through explanation, distance, etc. Just we can use it. Okay, so this is what we will do that here. We will say it's x minus the first coordinate of the center minus 1 square plus y minus 3 square equal r square, which is 34. So here is my answer. Now, let's explore the inverse operation. Suppose that I'm given equations of circles, okay? So I'm given the following ones. We have x2 plus y2 minus 12x plus 2y equal minus 36. Second, x, uh, yes, the second one is same x2 plus y2 minus 12x plus 2y equal minus 37. And the third situation is the same equation here, expression 12x plus 2y but equal minus 38. So the question is identify whether we have whether it is an equation of a circle. Okay, of a circle. So we see here we have a common expression. So to get to it, to be able to answer to this question, it's enough to bring something, my writing, modify the writing of my expression into something, a square in x, square on y, and the constant. Okay, so we know that we can do that using completing a square. So let's do that, starting just the equation, then try to answer. Okay, so let's do that. Okay, so first answer, so completing the square. So I rewrite my expression, regroup the x's, regroup the y's, equal minus 36. So the beginning of circle, the square here, it's x minus 2 times 6, so 6 square and minus, then if I develop, I will have plus 36, which I don't have, so I will subtract it. And here I have y plus 1 square and subtract 1. Okay, so if I move the constant to the other side, I will have x minus 6 square plus y plus 1 square. Okay, let's write it, yes, equal, then 37 minus 36, which is 1. Okay, for the situation 2, so let's, for the, yes, for situation 2, let's have here, second one, situation 2, so we will have only, instead of minus 36, we have minus 37. So we will have x minus 6 square plus y plus 1 square equal 37 minus 37, which is 0. Okay, and the third situation, we will have x minus 6 square plus y plus 1 square equal also 37 minus 38, which is minus 1. Okay, so let's try to conclude here. Here I see that I have exactly what I want. I have x minus 6 square plus y plus 1 square, okay, which is, I can write it differently here because I need a minus, so minus 1 square equal 1, and 1 is 1 square. So I see it's a circle with center 6 minus 1 and radius square root of, yes, which is 1 here. I already wrote it. So with radius 1. Now, so here we have an equation of circle. Let's explore here. The third situation says the sum of squares, which is positive, something always positive, equal to something strictly positive, no points. So uh, there are, so it's not circle, it's nothing. There is no point in the plane satisfying such equation. Okay, no point. That is, we have an empty set. There is no set of points satisfying these equalities, empty. What about now this one? This one we have a sum of two squares. This is something positive equal to 0. This will happen only if and only if you have this quantity 0 and this quantity 0. That is xy equal exactly 6 and minus 1. So this is only 1 point. 1 point. Okay, so this is yes. So an expression like that in containing degree 2 in x and y, linear term in x and y can be either empty, reduced to 1 point, or is a unit a circle.